we need to talk about a few rules before we can solve algebraically. Okay, so we're picking up on page 7 of the second unit. Greg, can you put that away? Just listen. Well, it's because it starts again in the new unit. I know, I'm sorry. Okay, so what is the limit as x approaches 5 of -2? To graph this, it might help. So what does the graph y equals -2 look like? A horizontal line through -2. Here's -2. So we're going to draw a horizontal line through -2. Oh, that kind of missed it. Okay, yes, we can. Yes, we can. We can find a limit. So it says, here's x equals 5. It says where our y value, as we approach 5, what y value are we going to approach? -2. Doesn't anywhere on the line, what will we always approach? -2. So what this means is, yes. So we're asking what y value it's approaching. Crazy, right? That's why you're plugging it into x plus 2 or whatever that equation was. Gives you the y. Okay, so when we take the limit of a constant, it's always going to approach the constant. Right? So if I gave you what is the limit as x approaches 2 for -3? Be -3. So whenever we have a constant, it's just equal to the constant. That's a C. So the limit of a constant is equal to the constant. Okay? Why? Well, because there is no slope, right? It's not changing. It's always going to be that constant. So you have some rules there, some laws. And we're going to prove every single one of those. I'm just kidding. That is beyond the course. Okay, so let's talk about limit as x approaches 3 for x. So let's graph the line y equals x. What does that line look like? It's just a line, right? What's the slope of this line? 1. 1. Slope would be 1. Right? It's just, no, it's 1, not 1x. Because the rate of change is just 1 over 1. A graph with the rate of change of the slope of x is actually this graph. Oops. I need to go through 0. Okay. Oh, no, it's actually maybe a little bit more stretched. Okay. So the slope, when we talk about the slope for y equals mx plus b, guys, and some of you did this in grade 10. You would say if it had 2/3 x, you'd say your slope is 2/3 x. No, because that means if there's an x there, that means your slope is changing.
So that would mean it would be like if it was actually 2/3 x squared plus.
It would be an x squared graph would actually form a linear slope. Okay, so what really matters here though is if your slope is changing, then there's going to be a variable in it. But on a straight line, is the slope changing? Is the rate of change changing? No, you got me. Okay, good. So the slope is constant, right? That's why the slope here is just 1. Just 1. It's always 1. Y is always increasing 1 for every x that's increasing 1. It's actually the other way around. But okay, so if we're looking for this limit, so if we're looking at x equals 3, what would we be approaching from both sides for the y value? 3. Okay, so that means, and that's always going to be the case, right? If I said x approaches 2, what would be the y value? 2. And so when we have a limit as x approaches a of x, what does that always equal? A. Okay, it's as if we're just plugging in that number. Plugging in 3 for x gives us 3. And numerically, that's what we're going to do. The formula is already given to us. Basically, sometimes it's already simplified, sometimes not. We don't have to create the slope equation. A squared. Okay, so properties of limits. Proofs are beyond curriculum. Basically, looking at this, the laws of limits, I'll show you an example using these laws and why they're kind of like, they follow all the numerical laws that we're used to. Okay, so there's no like weird laws like in logs, right? Logs have some weird laws. No? Log laws? Okay, I don't know. So all the numerical laws, so there's the summation law, right? So if you have two functions added together, we can find the limit individually and then add them together. Okay, we have the constant times a function. We can still do the limit of the function times the constant. There's the product, division, power, and then the radical. It's really all that we're used to. It's there. So let me show you an example using these laws. We'll do it once, and you're going to see how tedious this is, and we'll never do it again. Okay? And even on a test. Okay, so let's look at this example. So we want to break this up using the law of logs. Oh, where is it? Down here. There it is. There you are. Yours is on the next page, right? Oh, it's there. Great. Good. Okay, so I'm going to start with the summation law. What law is that? Law of 1. Yep. So what we're going to do is we're going to go the limit as x approaches 1 for x squared plus the limit as x approaches 1 for 3x. And so that was law 1. Okay? Now we're going to still use what other laws can we use? So I started you off with 1. The multiplication, okay, for who? The second? What law is that? Or is that the multiplication law? Okay, let's start with this guy. Yeah, write it down. Is there one for exponents? Is there an exponent law? Yeah, what number? 5, right. Okay, so we're going to write that as the limit as x approaches 1 for x, all squared. So that was law 5. Plus, what can we do with this? A constant times x. What law is that? Law 2. So we can bring the 3 outside. So 3 times the limit as x approaches 1 for x. And that was law 2. Now, why did we do that? Well, we just proved already that the limit as x approaches a of x is always a. So now we can actually solve this. Because what would this be here? 1, so 1 squared plus 3 times, what would this be? 1. Okay, do you notice anything?
No.
Oh, no, okay. So that equals 4. What are we supposed to notice? I don't know. Take a look there. Do we really have to do all that work? Okay, let me just, no. Okay, if I just plugged in 1, would I get the same answer?
Yeah.
Yes. Yes, okay. So from now on, when we algebraically evaluate limits, the first step is just to sub it in. That number in. Yeah. Okay, so that's easy, right? So to find the limit of most functions, you can simply substitute. So often, most often, I would say, the limit as x approaches a for f of x is just equal to f of a. So just plugging in x is a. It's often the case. And if that's the case, then life is easy, especially if it gives us a nice answer. And numerically, so let's try the next guy. Let's just subbing it in. Now, it's important to note, once you sub in the value, you don't write limit anymore. Okay? So when you sub a, you don't write, this is one of the, it's a common mistake. Once we sub, we don't need to write limit because we're actually evaluating the limit now. You don't write limit anymore. So I'm actually going to sub here -2 for x. 4 times -2 plus 7. And then -2 squared plus 1. Notice we don't write, as soon as we sub, we don't write limit anymore. Keep writing limit if we're just rearranging this, simplifying this. If I was like factoring the bottom or whatever, then we'd keep writing. But as soon as we sub, the limit's gone. We don't write limit anymore. Okay, what does that equal? 4 times negative 2 plus 7 is negative 1 over, oh, not negative, yeah, negative 1. Over, yeah.
Positive. How did that become a positive?
Where? Oh, no wonder you guys were fighting. I was like, what's going on here? So it's my fault. So it's actually 3. 4 minus 1 is 3. Okay? And then that's what it's actually approaching. So that's our answer. Done. Woohoo! To give you your assignment, you can basically finish a whole bunch now. Okay, so let's talk about properties of zeros. In math, the number that always gives us the most grief is 0. Seriously, not 9. Okay, 0. 0 causes problems. Okay, often. So let's talk about our different rules. 0 times a number. 0. Okay. If we have a number over 0.
Undefined.
That's undefined. Yeah. What? Why did I say in? Is
Oh, there it says negative 2.
undefined. So you can use this symbol. Is that what that's what you're saying? No? Is that what you call the apocalypse? The world just ended? No, you think the world ended. Just wait. I'm going to show you something worse than a number divided by 0. Seriously. Okay, well first, what's 0 divided by a number?
Does that make it real?
Okay.
Is undefined.
Okay, what's 0? Okay, what's 0 divided by a number? 0. Okay, what do you think is worse? It's another 0.
0. Square root of 0.
No.
Over 0 again. 0 over 0.
0 over 0 is actually the worst. The worst. Okay, so it has a name. You haven't seen it before, probably. It's called indeterminate, meaning cannot be determined.
But isn't that the same
Okay.
as undefined?
It's nope. These are two different things.
So what can you do with x over 0?
Okay. So
Multiply by
let me go through that in a second. So let's write this first. So it's called indeterminate. Determinate. Big word. Cannot be determined. So often when we have indeterminate, it's actually something else in disguise. So we have to algebraically manipulate the expression. So something like, because right now, the reason this happens is something is obviously needs to cancel. Okay, so an example where this happens, well, we're going to go through some in a second. That's probably the best way to do that. What we're going to do is if you ever get number over 0, it's undefined, does not exist, so no limit exists. That usually forms, right, an asymptote at those points, or it's a hole. If you get 0, 0, this is called determinate. And so what we're going to do is we're going to algebraically change. So if it's a rational expression, we're going to factor. Something should cancel. If it's a radical, guess what we're going to use? How do we rationalize? What's it called? Conjugate pairs. I spelled conjugate. Is it an E here?
No, it's easy.
Yeah? Yeah, like this? No. Okay. I can't spell. Usually math words I'm okay. Okay, so let's look at an example. So first step is we always try and sub the value in. So let's try it. Sub it in. See if we get a value. So 5 minus 5 over 5 plus 9. What does that give you? 0 over 14. Is that okay? What does that equal? 0. So that it's approaching 0. Okay. Let's try the next guy. So sub it in. 1 over negative 3 plus 3 gives you 1 over 0. So we would say the limit does not exist. Undefined, yeah. Okay, let's try the next guy. So 4 squared minus 16 over 4 minus 4. What's that going to give us?
0 over 0.
Indeterminate. Uh-oh.
So why is it worse?
Well, we just show 0 over 0. Just show 0 over 0. No, there's nothing cool. Or you could just show 0 over 0. Okay? So at that point, life sucks. We need to change our equation. Okay? Something obviously is causing it to be 0 over 0. So what we're going to do is we want to factor this guy because he's a rational expression. So we still write our limit. Can you factor the numerator?
Yeah,
X minus 4 times x plus 4 all over x minus 4. Woohoo! There's our issue. When we're subbing in 4, here's our 0 over 0 problem. So guess what cancels?
How is it possible that the same thing can equal two different things?
Well, we're talking about what it's approaching. So if I graph this equation, where's my thing that we use graphing?
Circles.
Okay, let's graph this thing. If you have a graphing calculator, graph this.
Jericho. It's like
Okay?
Jericho.
So if you have a graphing calculator, let's graph this guy.
What does it say?
So we're just saying, well, in this case, yes. X squared, what was it? X squared plus minus 16? Yeah, because the difference of squares. Over x minus 4.
What's going to happen?
Okay, make sure you're regular. Zoom. Zoom. 6 to restart. Now, you can't really tell at this point what's going on. It looks like a linear equation. But right now, if you put in, how do you do value again? You go trace, and we're approaching 4. Enter. It's actually a dot at that point. If we zoom in, there's a hole. No, just at that one. So, why? Okay, so zoom, zoom 3, zoom. I could even do decimal. Why don't I change my windows? Because I want to go at 4. So I'll go negative. No, not negative. I'll go 3 to 5. And then y 3 to 5. Why am I not seeing it? No.
What is it? Oh, it doesn't exist. Oh, it does.
No, I think it's my y values. Because it's obviously, what's the equation? Did it show you the dot? Yeah, there it is, see? There's a hole in the graph. So, what we're finding out is what it's approaching from both sides. Right? What is it approaching? Okay? And so, yeah, if you plug in that value, will it give you the answer? No. But now once we change the equation, we can figure out what it's approaching.
So we can figure out those two values right on the side.
Yes, that's what we're really doing. Okay? So, going back to where we left off, indeterminate. So now we have limit. We still write limit until when?
It's gone. Oh, look at the. What? Did you see that?
The light show? Okay. Yeah, I'm recording. We're good. Thanks, guys. Yep. Okay. Now can I sub in my value? Yes. Gives me. Do I need to write limit anymore? No, you keep writing limit until you sub in the value for x. Sorry, guys. So we always write the limit until we sub. Then we don't write limit. Yeah?
Under limit, you always write x stores 4.
X is no, it's not storing. It's approaching 4. You're graphing calculators, I tell ya. Okay, as x is approaching 4. We want x to approach 4. Yeah, so that gives us our answer of 8. Well, if this was the equation for slope, then yes.
So the slope is 8, but
So whenever you get 0 over 0, Okay, that's not the answer. You get 0 over 0 because you subbed initially. We always check first. And then we go and alter the change. Whenever we get 0, 0, we need to alter the equation. Okay?
What if you can't?
So 0, 0 just means
You can.
What if
You will always be able to.
over
You'll always be able to.
So what does 8 represent?
Okay. Well, if this was the equation of the slope, like really what it represents is at 4 from both sides, this equation, it's approaching 8. Y value of 8.
Y value 8.
Of 8 from both sides. Okay, I'm doing this a lot. Okay. So let's try this guy. Plug in, we want x to approach 0, so let's plug in 0. 0 plus 4 minus 2 over 0. What do we get? 0 over 0. So with a radical, what are we going to do? Conjugate pair. So we need to write, it's really annoying writing limit all the time. We have to write it until we sub. Lime? No. Lime has an E. Right? Okay, so we're going to multiply top and bottom by what? Yep. Somebody?
Never mind. Wait, you were gonna say something.
Root x plus 4. We're making a difference of squares.
You're rationalizing.
Yes, you're plus 2. We're rationalizing. And so top and bottom. Now here's my hint. This is the one that we're using the difference of squares on, right? The numerator. So we're going to leave the other one factored. Okay, don't expand that. Because ultimately we want something to cancel. So we're going to leave it factored. So the numerator becomes, let me expand this, x plus 4, right? Because root x plus 4 times root x plus 4 is, oh yes, I did it. It is so, yes, you lose marks. Absolutely. I would do that. Okay, and then negative 2 times positive 2. I don't know, yeah. Sorry. Okay. And the bottom we're going to leave in factored form. You guys with me?
Yes.
Yeah? Okay. What's going to happen on the numerator? 4 is going to subtract, and then we just are left with the x kills the, okay. Or reduces, one or the other. That was really, reduces. Okay, so reduces to, can reduce out the x. So 1 over the root of x plus 4 plus 2. Now that something canceled, we have, Vincent, you're here? Okay, got it? Okay, when something reduces, that's when you can sub something, because this is what's causing the 0 over 0. Oh. So let's plug it in now. 1 over, do we need limit once we sub?
No.
No. Before that, yep. So square root of 0 plus 4 plus 2, what is that going to equal? 1/4. Oh, that was a lot of work. So this function, as we approach 0, the y value from both sides is approaching 1/4.
Never mind.
All right, so that is the end of section 2 lesson, and we have to go on to lesson 3. Yay, I got to stop the recording though.